Okay, 3.7 improper integrals. So normally, what is integration? We want to find the area under the curve, right? So for example, we have a definite integration, means that from lower bound to the upper bound, we have lower bound A and upper bound B. So we want to know about the area under the curve between A and B. Then we did integration, right? Now, this section we called improper integrals, means that we have a definite integration from the A, but we don't go to the B. But what if we want to integrate? Means that if we want to know about the area until positive infinity, how that happen, right? Then in that case, we don't use positive infinity. We don't want to use negative infinity, okay? We're gonna use limit, and then we change it to the positive infinity, negative infinity, label as t in this section, all right? In this book. So we want to find area under the curve. All right. Definition, let me write down definition, but I want to bring definition from my screenshot so that I can save the time. So this is the definition. All right, so we have a definition. Let me make it bigger. Look, I want to explain. This one, as I explained to you earlier, right? So we have from A to positive infinity, we want to know about the area under the curve, right? Then this one, we cannot use that. So we take the limit and then we level at the same spot as t there, okay? Then we're gonna find the limit when t approaches to positive infinity, okay? Then we see limit exists or not, okay? Second one, also, if we have the graph, this one is like this, right? So it goes to positive infinity. Oops. All right, this one looks like that. So negative infinity, and then from the B to the negative infinity, right? And then since negative infinity, we take the level t, and then we find the limit there, right? All right. Then if limit exists, number, that means we get the number, right? Answer is number. Otherwise, we call the diverging. Diverging means we have positive infinity or negative infinity. Okay, then if the limit exists, we say the convergent because answer is number. All right. Okay, then number 3, look, we have from negative infinity to positive infinity, right? So negative infinity to positive infinity. Then we split. So negative infinity to until 0 and positive infinity to until 0. Okay. Then same. If this one we say the limit exists, there must be both of them converges. Okay. Otherwise diverges. But then if one term is diverging, we can say that diverging whole thing, all right? Because divergence is super powerful, all right? All right. Either one or diverging, then we say diverging, okay? All right, let us do example so we understand this definition. determine whether the area between the graph of f of x equal to 1 of x over 1 to infinity. It's a finite or infinite. So finite means number, right? Infinite means positive infinity or negative infinity, all right? Okay, so we're gonna find the area under the curve from 1 to infinity, 1 over x dx. Okay, now infinity is not good, right? So we're gonna change it to t, and then we take the limit of that spot, right? So limit t approach to positive infinity, we have 1 to t, 1 over x dx. So we integrate this one, what do you get?
ln absolute x.
Excellent. So we have limit t approach to positive infinity. We have ln absolute value of x. Then we're gonna evaluate from 1 to t, okay? When t approach to positive infinity. All right, then limit t approach to positive infinity. Then we have ln absolute value of t minus ln absolute value 1. We're not really using absolute value because it's positive. All right, then look, what's ln 1?
Just 0.
0, good. All right, so this part is 0, right? Then when t approaches to infinity, so think about ln t, which is ln x, something natural log, right? So y equal to ln t, looks like the graph like that. So think when t approaches to positive infinity, then what's the graph behavior? We are following the graph, okay?
Goes to infinite, plus infinity.
Yeah, so this graph, when t approaches to positive infinity, this graph approaches to positive infinity, right? So positive infinity, and then the question said whether finite infinite, right? So we're gonna say infinite, right? So this means infinite. Then later on, we're gonna use this as divergent, all right? So if we get the answer positive infinity or negative infinity, we say divergent, all right? Now, second one. We have from negative infinity to 0, 1 over x squared plus 4. Now, this is the state whether the improper, so we call this is improper because we are dealing with negative infinity, positive infinity as upper bound, lower bound, and then later on we have a discontinuity. Improper integral converges or diverges. Okay. We can have this one as a lower bound, right? So we're gonna switch over t. Now we have to say that what the t is. Then we take the limit. t approach to negative infinity, and there's 0, 1 over x squared plus 4 dx. All right? Now, how do we integrate this one?
Arctangent.
Arctangent excellent. So we have 1 over x squared plus 2 squared. Then we have 1 over a. Arctangent, in this case, x over a plus c, right? So a equal to 2. Oops. So we're gonna have this one, limit t approach to negative infinity, 1 over 2, arctangent x over a, which is 2, and we're gonna evaluate from t to 0. Okay. Now limit t approach to negative infinity. We have 1 over t arctangent 0 over 2, which is 0, minus arctangent t over 2. Okay. All right, so we have to know the graph of arctangent. So this is that. There is asymptote at pi over 2, negative pi over 2. Then, I just don't want to. So, like, it's like this, right? So x cubed upside down, right? I mean tangent upside down, right? All right. So if, look, when t approaches to negative infinity, we following the graph. What is the graph of behavior?
Minus.
It approaches minus infinity.
It approaches minus pi over 2.
Yes.
It goes to minus infinity to like,
Okay.
but
Sorry
it
about
never
that.
goes below minus p over 2 on the y-axis.
Okay. Let me do it. The first one first, because I go over more the second one. Okay, so when arctangent is 0, what do you get? What do you get this one?
Win at work by communicating effectively.
The 0?
Excellent. This is 0, yes. So we get 0, right? So this is 0. All right, now we have arctangent t. Think about that because over 2 inside the number, inside the function. This one just telling us stretch horizontally, right? This number. Stretched horizontally. Okay, so think about this. We have, this is a much better sin x, right? So we have start to 0 like that. It's 2 pi, right? Then if we have sine x over 2, there is a stretch horizontally means, think about we are standing end of they cannot be end up, but think about we're standing there. Then stretch, I'm pulling, I'm standing on the next to the x-axis, right? Stretching. Then this will be like will be 4 pi, okay? Because I'm stretching, standing on the x-axis. Is it clear? I can write down here.
Yeah.
So the number is not really matter because number is too tiny compared with the positive infinity and negative infinity, right? So we can just ignore that, but I'm telling you by the transformation what they are telling us, right? Okay. Let's talk about this one more time. So we goes the negative infinity, then what's the arctangent? So we're following the graph, right? What is the approach? I said that there is a horizontal asymptote.
Negative infinity.
This getting close to negative pi over 2. Can you see that?
But never crosses.
Yeah, never crosses. Okay. So it's getting close to negative pi over 2. So we will have 1/2 0 minus negative pi over 2. Okay. Then we get pi over 4. Is it clear? Say, No? Yes or no? Okay, if you don't understand, please ask me after this class, okay? All right. Example number 3, we have negative infinity to positive infinity, right? Then we have x e to the x dx. Okay, same thing, state. Oh, so this is converge or diverges. We say this is converge because we get the number, right? Okay, limit exists. The limit approach to pi over 4, converging, we say, okay? Now, state whether the improper integral converge or diverge. All right, so look, we cannot use negative infinity in the integration because we have to have a definite integration, right? The number, right? Also here, then we split by definition time number 3 here, right? So we split negative infinity to 0 and another term with the addition 0 to positive infinity, right? Then there is negative infinity to positive infinity, all right? Now, those negative infinity and positive infinity, we change it to t. Then we take the limit. All right. So this will be negative infinity to 0, x e to the x dx plus from 0 to infinity, x e to the x dx. Okay, now we take the limit. This is not good, so we're gonna have, there is a t approach to negative infinity, and then we say t to 0, x e to the x dx. And also, this is not good. We make a t there, and we take the limit. Positive infinity from 0 to t, x e to the x dx. All right, so does anyone recognize how to integrate this one?
Yeah, we reviewed it yesterday.
Pretend we did not review. So what kind of technique we are using it? Huh? What kind of technique? Try to say or cannot pretend? IBP, okay, integration by part technique, we're gonna use that, right? Because this is a product of two functions, right? All right, then we have to mention that which one is U, which one is DV, right? Which one is U?
X.
X, good. Let U equal to X, then this will be DV, right? All right, then we have derivative. What do you get? Derivative of X, dx, good. 1 dx, good. Now, we have a dv, but we want to find the v, how? Oh, let me write that first. E to the x dx. How do we find the v from the dv? We did it in the first section. Antiderivative, right? Oh my gosh. Antiderivative. Mistake a lot. To get the v, right? Then we do that other side too. What do you get?
EX.
E to the x plus c. Okay, very good. So we have u dv, then we're gonna use uv minus integral of v du. We're using the formula. All right, so uv, u which is x, v which is e to the x, minus integral of v which is e to the x, du which is dx, right? Then what do you get this one? X e to the x, what's the integral of e to the x? We just did, right? Okay, we're gonna use the two terms. So we will have t approach to negative infinity. Then we will have x e to the x minus e to the x. And then we're gonna evaluate from t to the 0 plus limit t approach to positive infinity. We're gonna write down same. And then this one we're gonna evaluate it from 0 to t. All right. Okay. Now, let's talk about negative infinity first. Only this one. So limit t approach to negative infinity. So we input the 0 there, then first term is 0 and minus e to the 0 power, negative t e to the t minus e to the t, right? All right. T So y equal to t, like that. So when t approach to negative infinity, we following the graph. What's the graph behavior?
Negative infinity.
Negative infinity. So this one, negative infinity, we slightly write down. What about e to the t? So this one looks like that, right? So when t approach to negative infinity, right? Then what's the graph behavior?
It approaches 0, but never.
Excellent. It's 0, right? So it's 0. Then this one also approach to 0, right? Okay, now then we have to think. This is we called another color. We have indeterminate form. Okay, so we have this kind of, and then this kind of inside the negative infinity or positive infinity or positive infinity or negative infinity or negative infinity or over negative infinity. We include there. And also we have 0 times infinity or negative 0 times negative infinity or infinity times 0 or negative infinity times 0 is included there. Now, infinity to the 0 power and infinity minus infinity. Okay, those kind of things. So we say that indeterminate form from the calculus 1. So if you studied OpenStax, and OpenStax is free, right? So you can access easily. So it's a calculus 1. 4.8 section. Okay, so review for that. All right, what we are doing right now. So what about e to the, we have to finish that. So indeterminate form. All right, so we have t, e to the t, right? All right, now how do we do? So indeterminate form, then we can apply the L'Hopital rule, right? So in order to apply the L'Hopital rule, it must be fraction form, right? So that we can derivative numerator and denominator respectively, right? So this one, we want to say t over e to 1 over e to the t. Okay, now this is a fraction, so we can apply the L'Hopital rule. So let us do this. This one we can say that limit when t approach to, what was it? T approach to
Infinity.
negative infinity. Negative infinity, right? So we have derivative t respect to t, and derivative of e to the negative t. How about that, right? Much better, okay? All right, now limit t approach to negative infinity. We do derivative with respect to t. What do you get this one?
Yeah, 0. Oh, just 1.
Just one. Good. Thank you. All right. So we do derivative with respect to t. So we there is a t. So
Just
what is the derivative
t.
of e to the negative t? It's a negative e to the negative t, right? Okay. Now, since we have negative power in the denominator, we can say that this is the same as limit t approach to negative infinity, negative e to the positive t, because we bring up, right? Okay, without negative power. It's okay? All right, then this one, think about, look, we have e to the t like that. Then this one telling us what? Okay. Think y equal to x squared, y equal to negative x squared. What do you get? How do we do this? This one open upward. What about this one?
Open to with the
Open downwards, right? So if we have e to the x, e to the t, then this will be like this, right? So we called this one is reflect about excellent, reflect about the x-axis, good. So this means reflect about x-axis, all right? Okay, now we're gonna think when t approach to negative infinity. So what is the graph behavior?
It's goes to minus infinity, but never crosses 0. Never
Is it-
become positive.
Okay, is it close to the 0?
Yes.
Yeah, good. Okay, so this is 0. All right. All right. So we will have so this will be everything is at 0 except e to the 0. What do you get? E to the 0. So let me write down e to the 0. E to the 0 power, any 0 power, what do you get?
1.
1. And everything was 0, right? So we get the -1 for the only left term, the first term I meant, okay? Now we're gonna do it's a little bit messy. So we are doing this one right now. Not this one. We did that. We're doing this one, okay? All right, so let me write down limit t approach to positive infinity. We have a t, e to the t minus e to the t minus, and the first term is 0 minus e to the 0. All right, now, what do you have with this one? We did earlier, when t approach to positive infinity, what do you get this? We have here. So we going to t approach to positive infinity. What is the behavior of the graph?
Infinity.
Infinity, good. So we have infinity. How about e to the t when t approach to positive infinity? Okay, what's the behavior of the graph?
Infinity.
Infinity as well. So we have an infinity times infinity, which is infinity, okay? All right, then we don't have to do anything else because infinity is really, really strong and powerful, right? We don't care about the other term. Yeah, okay. So we have infinity. So we will have infinity here. Okay. Now we can conclude. Look, type 3 say that either one is divergent. So look, this is convergent because we get the number, limit exists. We have a divergent because we have positive infinity. So one of them divergent, as I said, positive infinity divergent is more stronger superpower. So we say that whole thing is divergent. All right, so we can conclude negative infinity to positive infinity, x e to the x dx is goes to positive infinity. So we say that divergent. Okay. All right, good job. Okay, we do this time integrating discontinuity integrand. So let me denote continuous CTS. Okay, discontinuous integrand. So type 1, oh, we have, I did a screenshot. So screenshot. Cut. So we have this one. This is the biggest one I can make. Oh, why this one? Okay, I made a highlight, it was not clear, so let me erase. Okay, so we have, look, we have B is open, so B is not good, okay? So it must be continuous when we integrate, all right? So calculus 1 we learned the function must be continuous and then close the interval, right? Then this time not continuous at the end, so not the close, right? We did not include the point. So then look, this one looks like this. This one. There is asymptote from A to B, okay? So B is not included there. So then we take limit at B spot, then we replace T there, and then we say that T approach from the left, okay? So going to the left in this case. All right, this one, look, A is not included there, which is discontinuity at there. So it looks like this. So we have A, So there is asymptote. Okay, then look, we can say that T approach to from the right, and then we make replace T at the A spot, right? Okay, so from the right. All right, the third one we have AB is closed, but then except C, okay? That means C is not continuous there, all right? Okay, then this kind of graph, oops, little close. Don't say that there's touch, not touch. Okay, here there's asymptote, right? Then in the case, the 0 is not continuous, right? Which is C, right? X equal to C, which is 0 in the case, all right? So we split two terms like earlier, type 3, we have a negative infinity to positive infinity. We split from negative infinity to 0, and another term, which is 0 to infinity, all right? So here is the same, okay? Now, same concept. If we get the number, limit exists, and then we say converse it. If we have positive infinity or negative infinity, then we say the divergent, all right? And the type 3, either one is diverges, then we can say whole thing is diverging. All right, so let us do problem. So we have from 0 to 4, 1 over square root of 4 minus x, okay? All right, so look, think we have square root of 4 minus x, right? Then this will be minus x plus 4. Then we can factor out with the negative sign. All right. So what is it telling us by transformation? Just we learned the pre-calculus transformation. What is telling us?
It kind of flips on the y-axis.
Yeah, reflect about y-axis, right?
Yeah.
Okay, very good. How about this one? What is telling us?
Shift right 4
Shift
units.
good. Shift to right 4 units. Very good. So this means if we have another thing, so we have square root, looks like a square root. Then we say that reflect about y-axis. So this will be like this, right? Then shift to the right 4 units. So this will be like that, okay? Okay, so this is 4 minus x. Okay, then look, limit, we following the graph, right? So from the left side, approach to 4. Make sense? Okay, so we do that because after 4, we don't have a graph there. So let's write down limit T approach to 4 from the left, what I just said. And we do from 0 to t, 1 over square root of 4 minus x dx. Okay, so you guys to think about that. How do we integrate? Looks like it's something going on, right? But nothing going on. Nothing going on. Then we're gonna use just a power rule. Oh yeah. We have to use sub. I see. Use sub. Because we have a negative sign there. I totally forgot. Okay. Use sub. Go. Let u equal to what?
4 minus x.
Very good. 4 minus x. Then du, which is
Minus x dx.
minus dx, right? So we don't have a negative, so we divide by -1 there, right? So we will have so from 0 to 4, we put the negative sign and u to the -1/2 du, right? Okay, now limit t approach to 4 from the left. So what do you get? Antiderivative
Minus 1 divided by 2.
1/2.
Yeah.
Okay,
Yeah.
good. And then we're gonna evaluate. Oh my goodness, why did the t t t? So we change that from 0 to t. Then we're gonna change u back, which is 4 minus x. Okay. So, all right, so look. Okay, so we have 4 minus t. So looking at this one, and then t approach to 4 from the left, how the graph of behavior. T approach to 4 from the left. What's the graph? So basically, what's the y value then? Because we're following the graph. What's the y value?
At point 4, it will be 0.
Good, it's 0, right? So. Okay, so we will have -2, 0 minus square root of 4, which is -2. What do you get? It's 2, so negative is positive 4. Okay, now it's a converging or diverging?
Convergent.
Convergent, because we get the number. Okay, good. All right. Okay, we have from 0 to 2x ln x dx and state whether let me make it short, converges or diverges. Okay, now look, we have ln x there, right? Then ln x ln x, right? There is an asymptote, right? And we cannot have a 0, right? So we're gonna make t approach to from the right to approach to 0, right? So we will make that. So limit, we're gonna make a t on the 0 and then t approach to 0 from the right. Can you see that? And then to there, x ln x dx. Okay, now how do we integrate this one? How do we integrate? What kind of
Integration by parts.
excellent integration by parts? So let us do this. So we have x ln x natural log. Which one is u? Which one is u? Which one is the dv?
ln x. Or just x.
U ln x is u. Good. And this is dv. All right. What's the derivative of ln x? I know you know. What's the derivative?
Just 1 divided by x.
Excellent. Okay, dx. All right, so we have a dv, which is too fast, huh? We have a dv, which is x dx. Now we want to integrate to get the v, right? Then what do you get?
I mean, that would be
What do you have? Integral of x?
1.
1/2 x squared.
X squared over 2 plus c. Okay, I have a heavy plus c. All right. Okay, now we're gonna make uv minus integral of v du. So uv, which is ln x, v, which is, let me write down x squared over 2 in front because I don't want u multiply with x squared and then x there. Okay. Now minus the integral of v, which is 1/2 x squared du, which is ln x. Oh, no, du, it's 1 over x. Sorry about that. I thought it was
1 divided by x.
1 over x dx. Okay, thank you. All right, so then we have simplify. There is x. So d2 minus 1/2, we have x dx, d2 minus 1/2. We integral of x, what do you have? Same thing over here, right? So we have a x squared over 2 plus c. Yeah. Now, let me write down everything here. So we will have t approach to 0 from the right and x squared over 2 ln x and minus 1/4 x squared. I did not make a mistake, right? So we're gonna evaluate from t2 to, okay? All right. Now we do substitute upper bound to lower bound, which is t approach to 0 from the right. So this will be 2 square over 2 ln 2 minus 1 over 2 squared. Can you please calculate? And let's see, t squared over 2 ln t, oh, no space. Okay. Let me see, t squared over 2 ln t minus 1 over 4 t squared. Okay. Let me erase this part. Okay. I know the left term is the constant, right? So let us do that later. Once we have a second term as the positive infinity or negative infinity, the whole thing is divergent, right? So we don't need that. All right. So look, let's work. Right side, now our right side is the second term first. Okay, now t squared. So think about this. T approach to 0 from the right. What do you get? The y value. T approach to 0 from the right. The function behavior y value approach what?
0,
Zero.
oh, like
Zero?
0 in the bottom and infinity in the top.
So it's 0. How about LNT? We did the LNT earlier. So t goes to 0 from the right. What's the graph behavior?
Oh, it's going to infinity.
Excellent. Going to the negative infinity. So we have a going to the negative infinity. Okay, so this is indeterminate form again. All right, then so in order to use L'Hopital, we have to make the what is called fraction form, right? So we're gonna make a fraction form. Let's just ignore the 1/2, okay? And then we talk about the t squared ln t. So we can express this one ln t over 1 over t squared. Do you agree?
Agree.
Yes, good. Now, look, ln t when t approaches to from the 0 is a negative infinity. And then look, this is also, it's a positive infinity, right? So which is also indeterminate form. All right, then let us use L'Hopital rule. So t approach to 0 from the right. Derivative of ln t, we get the 1 over t.
One.
Oh, good. Over derivative of 1 over t squared. So it's better we have using power rule, so t to the negative t, right? Negative 2, sorry.
Just t minus 2 t and -3 in the top.
Okay. All right. Oh, would you like to include the 2? Okay, that's fine too. So yes. So we get the 2 here, then we get the same answer, 1 t squared. Okay, that's correct. Yes. Then we have to using 2, so it's a 4, -4. Okay, now then we simplify. So we have limit t approach to 0 from the right, 1/t, and that's the t to the 3rd power, -4. So we simplify, we have a 2 there. So this will be limit t approach to 0 from the right, -4t squared, right? So what do you get this one? It's the same thing. We have a -4, this means we think, right? So when t approaches to 0 from the right, what's the graph behavior? What is the y value?
Yellow.
0 there. So it's 0. Oh, we don't get the. All right then. Look, we have to work through. Well, let me see. Okay, come on, I don't need the time. I cannot move. Scroll up, scroll down. Okay, all right. So this is 0 we just found. What about this one? We just found this is 0, right? What about this one? We just is 0, right? This is 0. Yeah, we just did yeah, negative with the t squared. When t approaches to 0 from the right is 0, right? Now, let us just calculate this then. Okay. This is 1. So we have only the number. So 2 and with 1. So we have a 2 ln 2, correct? And -1. Can you make an approximation this one? How much? So is it converging or diverging?
It's convergent
Thank
because
you.
we get a definite number.
Good. So I'm waiting someone make a
It's 1/2.
Oh, approximation decimal, please.
Okay.
You got it? Point 382, I'm sorry. 0.3629. Thank you very much. All right. Okay, now the last one for today. So we have a -1 to 1 and 1/x cubed. So think the graph looks like that. Okay, so this is exactly same type of number 3 in the discontinuity, right, earlier. Then let us split. So this one with limit and -1 to 0, right? 0 is the discontinuity there because asymptote. All right. So we split this way, right? 0 to +1 and 1 over x to the 3rd power. It's better we have a power, so I want to write down power. X to -3, then you know what this means, right? Okay, we take the limit after this, yeah. I'm going fast. All right, so 0 is the spot, right? So we make this side from the left, we make this one is from the right. Okay, all right, let's do this one. -1 to t. To the 1. Okay, now so we do antiderivative of x to the -3rd power. What do you get?
X divided by -2 and to the -2.
-2 over divided by 2. Good. Oh, too many negatives, yeah. Okay, so does it here, right? And then we do evaluate from -1 to t. We do evaluate from the t to the 1. Okay, now basically this is, think about 1 over x squared, right? Before that, let me input all the values. It's 1 over x squared. So it will be 1 over 2t squared, right? Minus, oh, very confusing with the sign, negative, and then we have, how about factor out the negative, right? So factor out the negative, then we have a positive, negative, and then 1 over -1 to squared, right? How about factor out with the negative 1/2? Okay, so be careful, this is from the left. All right, so then we have, we don't need 2. Just like that, right? Okay, then plus same -1/2 factor out, and then we have a limit t approach to 0. Wait, 1 is the positive here, and then we do 1 over t squared minus oh no, it's 1 squared, and this is 1 over t squared, right? Okay. Now think 1 over t squared, which is looks like this, right? When t approaches to 0 from the left, What's the graph behavior?
Go to infinity.
Positive infinity, right? Done. We don't have to do any others. Okay. Yeah, so we can say that what? Converging or diverging?
Diverging.
Divergent because we have an infinity.
Excellent. All right. Thank you for coming today.